Right now, while you're watching these words, something is still sitting on another world. It has not moved in years. Its wheels remain pressed into a landscape no human being has ever touched. Its cameras are pointed toward a sky that fills with dust more often than clouds. It is not a satellite. It is not a lander. It is not even the newest machine we have sent there. It was built before smartphones became common, before streaming video dominated the internet, before many of today's engineers had even started their careers. For more than 14 years, it survived in one of the harshest environments ever explored by humanity. It crossed 45.16 kilometers of Martian ground. That is farther than a marathon. Imagine walking from one side of a major city to the other, except every single step happens on another planet. Then, in 2018, something happened. The researchers were not describing the event with words like interesting or unexpected. They were talking about a storm unlike anything they had ever seen on Mars. A storm capable of hiding an entire planet. A storm that slowly erased sunlight itself. This is the story of opportunity. And here is the part the headlines are not telling you. It is not simply about the last signal a rover ever sent. It is about what that silence taught scientists about surviving on another planet. It is about what is still happening on Mars right now, that engineers continue to study whenever they design the next generation of robotic explorers. And it is about what those lessons could mean for the day human beings finally attempt to live there. Stay with me, because by the time this is over, you will never think about a silent machine the same way again. Every great space mission begins with a problem. In the late 1990s, NASA faced one that seemed almost impossible. Mars looked familiar through telescopes. It had seasons, ice caps, ancient river valleys, dry lake beds. Yet one question refused to disappear. Had liquid water ever existed there long enough for life to have been possible? Orbiters could photograph enormous regions. They could map mountains. They could measure minerals, but they could not pick up a rock. They could not examine tiny layers inside ancient cliffs. To answer those questions, scientists needed something very different. They needed a field geologist. Only this geologist would have to survive alone on another planet. One of the people helping make that possible was Steve Squires, a geology professor at Cornell University. For years, Squires and his colleagues proposed sending a mobile laboratory to Mars. The idea sounded simple. Instead of landing in one place, let the robot drive. Move from rock to rock. Study different landscapes. Follow the evidence. Reality was far less simple. Every kilogram mattered. Every electronic component had to survive freezing nights that could fall below -100 degrees Celsius. Every instruction sent from Earth would arrive minutes later because radio signals travel at the speed of light, not instantly. Even at light speed, Mars is simply too far away. The rover would have to think for itself, at least a little, avoid obstacles, monitor its own systems, know when to conserve power, know when to wake up. That was an extraordinary challenge more than 20 years ago. Computers inside the rover were far less powerful than the smartphone sitting in your pocket today. Yet they had to make life-or-death decisions without human hands nearby. NASA approved 2 nearly identical rovers. Not 1, 2. If one failed, the other might still succeed. Their names became Spirit and Opportunity. Launching 2 spacecraft also doubled the scientific opportunity. Different landing sites meant different geological histories, different rocks, different clues, different chances to answer the biggest question: what happened to Mars? Opportunity launched aboard a Delta II rocket on July 7, 2003. More than 6 months later, it approached Mars. The spacecraft entered the atmosphere at roughly 19,000 kilometers per hour. That speed is difficult to imagine. Picture crossing an entire large city in less than 2 minutes. Now imagine doing it while surrounded by superheated plasma. Everything had to work perfectly. A heat shield slowed the spacecraft. A parachute deployed. Retro rockets fired. Massive airbags inflated around the lander. Instead of touching down gently on wheels, the entire spacecraft bounced across the Martian surface like an enormous rubber ball. It bounced again and again. Finally, it stopped. The airbags deflated. The petals of the lander unfolded. For the first time, Opportunity looked outside. Scientists could hardly believe where it had landed. The rover had come to rest inside a tiny crater, later named Eagle Crater. Instead of spending weeks driving to reach exposed bedrock, the bedrock was already there. It was almost as though someone had placed a geologist directly inside an open road cut, where millions of years of history were waiting to be read. Researchers later described the landing as extraordinarily fortunate. Opportunity had been designed for a mission lasting just 90 Martian days, called sols. That was the engineering requirement. Everything beyond that would be considered a bonus. No one expected the rover to remain active for years. Certainly not for 14 years. But Opportunity had a habit of rewriting expectations. Its first images showed layered rocks unlike anything previously studied on Mars. Its instruments soon detected minerals called hematite. On Earth, these often form in the presence of liquid water. That did not automatically prove ancient lakes existed. Science rarely works that way. One clue is never enough. But it was exactly the kind of clue researchers had hoped to find. And it was only the beginning. Over the years, Opportunity would drive farther than any vehicle had ever traveled on another world. It would climb crater rims, descend into valleys, photograph dust devils sweeping across the horizon, witness changing seasons on Mars, and repeatedly survive conditions engineers believed might end the mission. Each success made one uncomfortable fact harder to ignore. The rover was dramatically outliving every prediction. But surviving Mars was never only about building a tough machine. Eventually, Mars always gets the final vote. And in 2018, that vote arrived in the form of something almost unimaginably large. Not a meteor, not mechanical failure, not an accident, just dust. So much dust that it nearly erased the sun itself. The last transmission wasn't a farewell. One of the most persistent myths about Opportunity is that it sent a heartbreaking final message. You may have seen headlines claiming the rover's last words were something like, "My battery is low, and it's getting dark." It is an emotional sentence. It is also not something Opportunity actually transmitted. That line originated from a journalist's interpretation of the rover's final engineering status, not from the rover itself. Opportunity did not speak in English. It transmitted telemetry, numbers, status reports, engineering data. Think of it like a hospital heart monitor. The machine does not tell a doctor, "I don't feel well." It reports pulse, oxygen levels, and blood pressure. Doctors interpret what those numbers mean. Opportunity worked the same way. Its final communication on June 10, 2018, contained engineering information showing the rover was experiencing extremely low available energy as the global dust storm intensified. There was no dramatic goodbye, no farewell message, no final speech, and somehow, that reality feels even more powerful. Because the rover did exactly what it had always done, it kept reporting the facts, even as those facts became increasingly alarming. That quiet professionalism is part of why engineers still speak about Opportunity with such admiration. For 14 years, it simply continued doing its job. The storm that changed everything, the dust storm of 2018, did not appear overnight. Mars experiences dust storms every year. Most remain local or regional. Scientists understand the general process. Sunlight heats the surface. Warm air rises. Winds lift tiny dust particles. Those particles absorb additional sunlight. The atmosphere warms even further. Stronger winds lift even more dust. The cycle reinforces itself. Researchers call this a positive feedback loop. Imagine blowing flour into the air inside a room. Now imagine the floating flour somehow creating stronger fans that lift even more flour. That is a simplified version of what happens on Mars. Eventually, visibility becomes astonishingly poor. Orbital spacecraft watch the storm expand across enormous portions of the planet. Within weeks, Opportunity's landing region had almost disappeared beneath the haze. The amount of sunlight reaching the rover fell to extraordinarily low levels. Solar-powered exploration suddenly became a race against darkness. NASA engineers knew exactly what was happening. The difficult part was that they could do almost nothing about it. No command from Earth could clear the sky. No software update could remove airborne dust. No backup generator existed. Opportunity simply had to wait. That waiting became one of the longest periods of uncertainty in Mars exploration. Every day, the team checked for a signal. Every day, they hoped the atmosphere had become just a little clearer. Every day, they wondered whether 14 years of extraordinary exploration might already have ended. Listening to silence. As the storm gradually weakened, NASA began one of the most patient communication campaigns ever attempted. The idea sounds simple. Call the rover. Listen. Repeat. Reality was much harder. Mars does not always occupy the same position relative to Earth. Communication opportunities depend on planetary geometry. Orbiters relay some signals. Large radio antennas on Earth listen for others. Every attempt required careful planning. The Deep Space Network, a worldwide system of giant radio antennas located in California, Spain, and Australia, began repeatedly sending commands toward opportunity. Those antennas are among the most sensitive communication systems ever built. They routinely detect unimaginably weak spacecraft signals arriving from across the solar system. Imagine trying to hear a whisper from thousands of kilometers away. Now imagine that whisper comes from another planet. That comparison still understates the challenge. Opportunity never answered. Weeks became months. Months stretched longer. Engineers considered every reasonable possibility. Perhaps dust still covered the solar panels. Perhaps the rover's internal clock had drifted. Perhaps it was waking up at unexpected times. Perhaps a communication fault had developed even if the rover itself remained healthy. Every new possibility produced another carefully designed recovery strategy. NASA transmitted commands intended to reset communication systems. Commands designed to account for possible clock errors. Commands encouraging the rover to wake up and call home. Again, nothing. Researchers still cannot fully explain exactly why no signal ever returned. The storm alone may not tell the entire story. Years of extreme temperature cycles had already placed enormous stress on batteries, electronics, and wiring. After 14 years on Mars, far beyond its original 90-sol design life, multiple systems were operating well beyond their expected lifetime. Eventually, probabilities catch up with every machine. Still, the silence remained difficult to accept, because opportunity had surprised everyone before, again and again. It had survived winters, escaped soft sand, recovered after previous power shortages, benefited from unexpected cleaning events that removed dust from its solar panels. Each recovery made another seem possible, so engineers kept listening. Long after optimism became difficult, long after many people assumed the mission was already over, because one signal, one brief transmission, would have changed everything. The mission that refused to end. By early 2019, Opportunity had been silent for more than 8 months. Most spacecraft stopped working close to their planned lifetime. Opportunity did the opposite. It exceeded its original mission by a factor few engineers would ever expect. Remember the numbers. 90 sols. That was the design goal. The rover ultimately operated for nearly 15 Earth years, or more than 14 years on Mars. That difference is difficult to appreciate. Imagine buying a flashlight advertised to last 3 months. Instead, it keeps working every day for almost 15 years. You would eventually stop asking whether it was reliable. You would start wondering how it was still possible. That is exactly what Opportunity became. Every additional month produced new science. Every additional kilometer revealed another chapter of Martian history. By the end of the mission, the rover had driven 45.16 kilometers. No wheeled vehicle had ever traveled farther on another planet. That record stood for years and demonstrated something important. Mars exploration no longer had to mean landing, sampling one location, and stopping. A rover could become an explorer in the truest sense. It could travel, choose new destinations, follow geological clues, change scientific plans as discoveries unfolded. Opportunity transformed Mars from a collection of isolated photographs into a connected landscape with a history scientists could begin to read. And perhaps its most important contribution came from rocks, only a few centimeters across. What Opportunity actually discovered people often remember Opportunity because of its remarkable endurance. Scientists remember it for something even more significant: evidence. Shortly after landing in Eagle Crater, Opportunity examined layered sedimentary rocks. The rover identified tiny spherical features that researchers nicknamed blueberries. They were small hematite-rich concretions. On Earth, similar structures commonly form when mineral-rich water moves through wet sediments. That comparison immediately attracted attention. It did not prove life. It did not prove oceans. Science rarely jumps directly to dramatic conclusions. Instead, it added another independent line of evidence. Opportunity also identified minerals such as jarosite. Jarosite forms in acidic, water-rich environments. Again, scientists were careful. The finding did not tell them exactly how much water existed, or how long it remained, but it strongly indicated that liquid water had once interacted with the rocks. One discovery became another, then another. Years later, Opportunity reached Endeavour Crater, where it examined much older rocks than those found near its landing site. There, the rover detected clay minerals from orbit-confirmed targets and investigated geological environments that suggested some ancient Martian conditions may have been less acidic and potentially more favorable for liquid water than previously studied locations. Notice the difference. Researchers did not conclude Mars was once full of life. They concluded some environments appeared more habitable than scientists had previously understood. That distinction matters. Evidence should always be allowed to speak for itself. Opportunity helped establish one of the central ideas guiding Mars exploration today. Ancient Mars was not the same planet we see now. It changed. The difficult question is exactly how and exactly when. Researchers are still refining those answers. The day NASA stopped calling. Even after months without contact, NASA continued trying. Recovery commands were transmitted again and again. The Deep Space Network kept listening. Engineers examined every realistic explanation. Could dust still be covering the panels? Could a fault have reset the onboard clock? Could the rover wake up unexpectedly during a warmer season? Every possibility deserved one more attempt, because history had taught the team never to underestimate opportunity. Then, on February 13, 2019, NASA held a press conference. After more than 1,000 recovery commands had been transmitted without receiving a response, the agency officially declared the mission complete. It was not a dramatic ending. No final image arrived. No farewell transmission suddenly appeared. Instead, mission managers acknowledged what the data had been suggesting for months. The rover had almost certainly completed its work. For many engineers, that moment was deeply emotional. Some had spent well over a decade working with the same spacecraft. Every Martian morning had begun by checking its health. Every new image had arrived as another small conversation across millions of kilometers. Then, the conversation stopped, not because anyone chose to end it, because Mars finally became stronger than the machine exploring it. Yet calling the mission complete did not erase what Opportunity had already accomplished. The data remained, the photographs remained, the discoveries remained, and the tracks it left across Mars remain there today. With no rain, no flowing rivers, and almost no erosion compared with Earth, those wheel tracks could persist for an extraordinarily long time. They are, in a sense, one of humanity's longest-lasting footprints beyond Earth. Opportunity is silent, but its mission is not over. Every rover that followed inherited something from it. Curiosity, which landed in 2012, benefited from lessons learned about driving, navigation, and long-duration surface operations. Perseverance, which landed in 2021, carries those lessons even further as it searches for signs of ancient microbial life and collects samples for possible future return to Earth. Engineers still study Opportunity's engineering data, not because they expect another signal, but because understanding why machines survive or fail helps design better explorers. The next generation of Mars missions will travel farther, operate longer, and eventually support human explorers. When that day comes, many of the engineering decisions protecting astronauts will trace part of their history back to one rover that kept going for 14 years and covered 45.16 kilometers on a planet where it had been expected to survive for only 90 sols. So what does all of this actually add up to? At first glance, Opportunity looks like a remarkable engineering success. A rover that lasted 14 years instead of 90 sols. A machine that traveled 45.16 kilometers across another planet. A mission that continued producing discoveries long after anyone expected it to end. All of that is true, but it is also incomplete. Because Opportunity changed something more important than its own mission record. It changed how scientists think about Mars. Before the Mars exploration rovers, researchers already suspected that liquid water had shaped parts of the planet. Orbiters had photographed channels that looked like ancient river valleys. They had mapped minerals from hundreds of kilometers above the surface. Those observations were compelling, but they were still observations from orbit. Opportunity brought geology to ground level. It examined individual rocks. It measured their chemistry. It photographed microscopic textures. It compared one location with another. It helped transform broad ideas into direct field evidence. That distinction matters. Imagine trying to understand Earth's history only by looking out of an airplane window. You might identify mountains, you might recognize rivers, but you would never notice the tiny mineral grains that reveal how those landscapes formed. Opportunity became the scientist, walking across the ground. And because it kept surviving, it continued adding chapter after chapter to that scientific record. Its discoveries also changed the direction of future missions. Curiosity was sent to explore an ancient environment that scientists believed had once been habitable. Perseverance was sent to search for evidence that ancient microbial life could once have existed. Those missions did not begin in isolation. They built directly on discoveries made by spirit and opportunity. That is how exploration usually works. One mission rarely answers every question. Instead, it asks better questions for the next mission to solve. And Mars still has no shortage of unanswered questions. Researchers still cannot say exactly how long stable lakes existed. They still debate how rapidly the planet lost most of its atmosphere. They continue studying when Mars transitioned from a wetter world into the cold desert we see today. Some evidence points in one direction. Other evidence suggests a more complicated history. That uncertainty is not a weakness. It is how science progresses. Every new measurement narrows the possibilities. Every rover leaves the next generation with fewer assumptions and better evidence. Opportunity was part of that process, from the day it landed until the day it fell silent. Its silence also reminds us of something easy to overlook. Spacecraft do not fail because they become unimportant. Most fail because the environments they explore are extraordinarily difficult. Mars is cold, dry, dusty. Its atmosphere is thin. Its temperature changes dramatically between day and night. Every sunrise places another cycle of expansion and contraction on metal, wiring, seals, and batteries. Every gust of dust settles somewhere. Every winter reduces available sunlight. Eventually, physics wins. That is not a tragedy. It is simply the cost of exploring places where humans cannot yet go themselves. And yet, despite all of those challenges, opportunity accomplished something extraordinary. It never stopped doing the job it had been built to do. Its final transmission was not dramatic. It contained no farewell, no emotional message, only engineering data, the same kind of information it had faithfully transmitted throughout its mission. In a way, that makes the ending even more meaningful. The rover did not know it was nearing the end. It simply continued collecting information about another world. That is exactly what scientists had asked it to do. If there is a lesson in Opportunity's story, it is not that machines can become heroic. It is that careful engineering, patient science, and a willingness to keep asking difficult questions can accomplish things that initially seem impossible. A rover designed for 90 souls became a mission lasting 14 years. A vehicle expected to travel a short distance crossed 45.116 kilometers of Martian terrain. A mission created to investigate one landing site ended up rewriting our understanding of an entire planet. Those numbers are worth remembering, not because they are records, but because they represent thousands of small successes added together. One successful landing, one careful drive, one rock examined, one image transmitted, one sunrise after another. That is how exploration usually happens. Not through one spectacular moment, but through years of quiet persistence. And even today, Opportunity has not completely disappeared. Its data continue to be studied. Its discoveries continue to appear in scientific papers. Its engineering lessons continue to influence new spacecraft. Its wheel tracks almost certainly still cross the Martian surface, waiting beneath a sky where dust still rises with the changing seasons. One rover, 90 sols, 14 years, 45.16 kilometers, 2018. Four numbers that tell a story far larger than themselves. Because when Opportunity finally went quiet, the science did not. It simply passed into the hands of the missions that followed. And somewhere on Mars, a silent rover still faces the horizon, exactly where it completed the longest journey anyone expected it to make. If you enjoyed this documentary, consider subscribing and turning on notifications. Here on Proof, we break down real space exploration, real missions, and real discoveries, grounded in published scientific research, rather than exaggerated headlines. Because the universe is already astonishing enough, it never needed exaggeration.